We're supposed to find the area of intersection for these two circles. So a good idea would be to look at the graph of these two circles, and if you wanted to do that without the use of technology, you could. It would take some time. We have that x squared plus y squared equals r squared. So that's a converting equation we could use to put it in Cartesian form. Let's see, what can we do with this? So over here, this is the same thing as this if you multiply r to both sides. So this is also 3y, right? Because we have y equals r sine theta as a conversion factor from Cartesian to polar and vice versa. That y is r times sine theta. So we got 3y over here. So this becomes 3y. And now you've got to get this equation in standard form, so that means you've got to subtract 3y from both sides, and then you want to complete the square. I'm not sure if it's worth going through that. Divide that by cut in half. So you can complete the square, or I'm going to turn to technology just to give us an idea of the sketch, because that way we can get to the calculus part. So if you Google search polar coordinates Desmos, there's a graphing utility that comes up. And there's r equals, we need 3 sine theta, and then our other one for this problem is r equals 3 cosine theta. You can just type in the word theta and it pops up. So there's the two rings. So we just want that for a sketch so that we can start finding the area. I think it said the area of intersection. So we're looking at this area here. So when setting up the integral, remember this is blue is cosine, is r equals 3 cosine theta, and red is r equals 3 sine theta. So if you're not sure, how to make that integral happen, remember what r is. R is the distance from the origin to the wherever you're going to end your graph. So this is like at r equals this is r when theta equals 0. This is r when theta equals like pi over 8. R is whatever number it is that it takes to go from the origin to wherever your angle lands, depending on the formula. So what we want to do is we want to find the area in between these two graphs. So if we were to look at the r value for sine of theta, there'd be one really small one there, there'd be an r there, there'd be an r there. We could integrate so we could integrate for r equals 3 sine theta, because that would give us the infinite amount of different r values between here. But we want to stop it at 1/2, because if we were to keep going, then we're getting a little bit of r that is outside of our circle, right? We'd have an r that's out here. So if we stop at the cutoff point, which is a 45-degree angle, right, because of all the symmetry that's going on with the two circles. So we want to stop at pi over 4. We want our integral to begin at 0 and to stop at pi over 4. And then we're going to double this integral, whatever it is. So that's going to just basically mean that 1/2 goes away. And the reason is because if we can find out this area, then doubling it means that we're going to cover this. That's going to tell us how much is over here too, and we'll have the full area in between the curves. So we're integrating for r equals 3 sine theta. So we're going to plug in 3 sine theta in for r. That's squared. So that's the integral from 0 to pi over 4 of 9 sine squared theta. And then we can use our power reduction identity to make this an integral that we can easily digest. If you remember sine squared theta, that's equal to 1 minus cosine 2 theta. That reduces the power. And then we can break that up into 2 separate integrals. This is 9 times the integral of 1/2 with respect to theta, minus, got to distribute the 9 to the other part too. So this is minus the integral from 9 times the integral from 0 to pi over 4. Actually, no, it's still minus. Okay. Let's factor out the 1/2 here, because now it's an integral of this piece. So it's 1/2 cosine 2 theta over here. And that's an integral we can do, right? Kind of running out of room. Here, let me pause. Okay, so here's where we were at. This is 9 times 1/2 theta, because the antiderivative of 1/2 is 1/2 with respect to theta is just 1/2 theta. We evaluate that. The limits of integration are 0 and pi over 4. And then over here, this is 9 over 2 times antiderivative of cosine 2 theta. It's 1/2 sine 2 theta, because we have to accommodate the chain rule. So that's like a u substitution was made there. We evaluate those limits of integration as the same. And so over here, this is 9 times pi over 4 times, this is pi over 8. And then over here, sine 2 pi. If we plug in pi over 4 in for theta, I think I just said pi, but that's 2 theta. So if we plug in pi over 4 in for theta, that's sine of pi over 2. So that would be 1. So 9/2 times 1 is 9/2. And if you were to plug in 0, sine of 0 is 0. So we're getting down to the end here. I think that might be it. 9 pi over 8 minus 9 over 2. Yeah, I think that's it. I got something different than when I did this on scratch paper, but I'll go double check here. So I did miss something. I missed a 1/2 over here. Sine of 2 pi, 2 theta. When we evaluate that, that was 1. But this is 1/2 times 9/2, so that should be 9/4. There's our correct answer.